We are in chapter 6, lesson 4, and we're talking about geometric sequences and arithmetic sequences and what they mean. So, first of all, let's talk about vocabulary. A geometric sequence is a list where each term is multiplied by a common ratio. So, like every number, I multiply by 2, I multiply by 2, I multiply by 2. And so that would be the common ratio. The common ratio, as you'll recall, is the number in exponential functions that was it's the base of the exponent. So there's the number that was attached to the exponent. That was the common ratio in our lessons previously. An arithmetic sequence is a list where I'm adding. A list where each term is added by the same amount. We don't call adding a common ratio. We just say it's added by the same amount. So I might have a list that's like plus 5, plus 5. Every number I just add 5. Okay. Formulas. These formulas, this explicit formula is very similar to the formula that we have been using in 6.3 and 6.2. The first number, we called it the y-intercept, times the common ratio, raised to the power of n minus 1. N minus 1 means the number before it. So whatever the number was before it, we multiply by 3. So if I have a list, and let's multiply by 3. 4, 12, 36. I'm multiplying by 3, right? Well, if I'm trying to find 12, I have to look at the number before it, the n minus 1. So if this is the second term, the second number, I would do 2 minus 1 for the first number. So the n minus 1 means the previous term. You're going to see n minus 1 often. I am multiplying the common ratio by the last number in the list, the number before it in the list. That's why it's raised to the power of n minus 1. Previous number. So a is the first term, n is whatever number we're talking about, nth term. Maybe I want to know like the 17th number. A formula recursive has just the common ratio multiplied by the previous term. So these two are very similar. They both have common ratio, but I'm going to multiply the common ratio by the number before it. And here, the first term, and then the common ratio raised to the power of the previous term. So we're going to use both of these in different ways. Let's look at example 1 first and identify. Is it arithmetic? Is it geometric? And we say arithmetic, not arithmetic, arithmetic. Determine if the sequences are arithmetic, means add, geometric, multiply, or neither. Neither means there's nothing in common. These lists are just like random, nothing special. All right, 16, 12. What's happening with the 16? What's happening to negative 12? And then 9. This is a lot. What's going on? 16, negative 12, 9, negative 6.75. What's happening? And if you don't know, let me teach you how. Yeah. Times negative 3/4. Now you're like, how did he get that? Here's how we got that. You divide a number divided by the number before it. Previous term is a better way to say it. So it's like negative 12 over 16. Negative or positive 9 over negative 12. Negative 6.75 divided by 9. So what I'm doing is I'm saying, what's this going to reduce to? And that's going to be a way for me to figure out, am I adding? Am I multiplying? What's happening? So 12 sixteenths, 9 twelfths. These, when you reduce the fractions, you get what? It's 12 over 16. Reduce it to the lowest terms. Negative 3/4. Okay. How about 9 twelfths? Is that going to be negative 3/4? Well, let other people answer. Is it? No one's talking, so I don't really know if you're even like, hello. This 6.75 divided by 9 is a little harder, but the first two are negative 3/4. So it is going to be geometric because we're doing a multiplication. Negative 3/4, negative 3/4. So it's going to be negative, I could say negative 3/4 or negative 0.75. $24, 16.8, 9.6. What's this? So you can do, first of all, we could try dividing or we could subtract or add. So we kind of have to see what it is. 24, it's going downward, right? It's decaying, it's decreasing. 24 minus 16.8 or 24 divided by something. So it's like 16.8 divided by 24. That's kind of tricky, these decimals. So why don't you guys, can we multiply by something? Are we adding or subtracting something? What's happening? Do you guys want to grab the calculators? Because these, better to do that. Okay, why don't you guys grab calculators? So first we're going to divide, okay? I don't know why some of you are still sitting without calculators because you're just wasting time. We're recording. Can you close your Chromebook? We don't need Chromebooks today. Okay, can you guys do these division problems and see if it's because we have to figure out if it's arithmetic or geometric. So when you divide 16.8 Put that in the calculator first, divided by 24. What's that ratio? Huh? What? 0%? Oh, okay. What about 9.6 divided by 16.8? Is it the exact same ratio? No. What was this one? 9.6 divided by 16.8? 0.57? Okay, so it's not geometric. Okay, that means that we need to try subtracting. Am I subtracting by the same amount? 24, down to 16.8, down to 9.6. What's that? What's happening? Is it subtracting by the same amount? Okay, someone besides table 9. What's the amount? Yeah. 7.2. I'm going to call this arithmetic. And it's going to be minus 7.2. All right, 100, 80, 70, 65. Am I dividing by the same amount? Or am I subtracting by the same amount? The list has to have some sort of pattern. So, I've had one person give me their thoughts. How about the rest of you? Is there a pattern, multiplying or subtracting or adding? Yes or no? You already answered. No. I mean, you're fine here, but no one in the back. No, I've seen 3 people nod their heads, so neither. There's nothing in common. All right. So, 8 to 12 recursive formula. Here we go. The recursive formula means a sub n. I don't put anything at the beginning. I just write a sub n equals the common ratio. What's the common ratio? Eight to 12, 12 to 18. It's geometric, so I better do this on the side. 12 divided by 8. 18 divided by 12. What's that common ratio? This is example 2. 12 over 18, 18 over 12. Is that the same common ratio? What's 12 divided by 8? Huh? 1.5? What's 18 divided by 12? Oh, perfect. That means, here's the formula. R, sorry, it's right here where my pencil is. Common ratio, 1.5 times the quantity. So, I'm just going to put the previous term. And now there's all these terms in the list, but I keep in parentheses this a sub n minus 1. The minus 1 goes with the n. It doesn't go after the a. Okay? Tara has company stock with a steady decreasing value over the last week. How could she write an equation to determine the value of her stock in the future if it keeps losing value at the same rate? She's losing money on her stocks. It started at $859. It went down to $841, $824, $808, $792. So this is us first figuring out what's the common ratio. It's going to be like the number before it Okay, 841.82 divided by the number before it, 859. The next number, 824.98, divided by the number before it, 841.82. What's this division problem? What's this when I divide? Value divided by the number before it. $841.82 divided by 859. 7, say it again? And is this the same person responding over there? Okay, I need new people. You guys talk. Volunteer. It's the same people. Is 824 and 98 hundredths divided by 841 and 82 hundredths the same? Is it 0.98? No. It's not, you guys? Oh my gosh, I really can't hear anybody. Maybe it's the masks. So they're not the same ratio. This is not good. Let's do the third one. $0.98. It was the same, you guys. It rounds to the same. How come you guys are saying no? 808.48 divided by 824.98. Yeah, these are all 0.98. 0.98 hundredths. So that is my common ratio. My common ratio is 98 hundredths. Now, recursive formula. So I'm looking up above at my formulas. They're right here. Recursive means that I'm going to do the exact same one I just did. Common ratio, A sub n equals 0.98 times A sub n subscript. It means there's a little number below it. A sub n minus 1. Explicit. I have to write down the first term when I use explicit. So the first term is 859. A sub n equals 859. Oh, you can't see. 859 times the common ratio, 0.98, raised to the power of n minus 1. So in explicit, I have to do the first term. Recursive, I don't. So we're using our calculators to do dividing to figure out what's the common ratio. What is it dividing by? Or what is it being multiplied by? All right, let's move on. What is the 10th term in the following sequence? 8, 12, 18, 27, 40.5. Okay. Find the ratio. 12 divided by 8. We already did the common ratio. You guys, this is the same problem here. Example 2, the common ratio is 1.5, yeah? So let's remember that, I just did this list. 1.5. Now, to find the 10th term, okay, so the first term is 8. And the first term we describe as A sub 1. A sub 1 is my first term. That's 8. So I'm going to do A sub 10 equals 8. I'm doing the explicit formula. Explicit formula to find a certain term. 8 multiplied by, 8 is that, first term is 8 multiplied by 1.5 raised to the 10 minus 1. Now, do you remember how we have to do 10 minus 1 is 9? We have to do 1.5 to the 9th first. On your calculators, you need to do, just in case you're at home, let's say you're at home and you don't have this, my calculator. Here's the way to do it if you're using your iPhone calculator. And I actually showed the other period and I want to show you. So I go 1.5 to the 9th first. And I get my answer. And then you multiply it by 8. You have to do the order of operations. Times 8. 307. So the 10th term, 307.55, I'll round. All right, let's say that we are going to use our cell phone calculators. Okay. All right, here we go. Here's my cell phone calculator. If you're at home and you're using your cell phone calculator, here's how you do it. You have to turn your calculator horizontal, and it becomes scientific. Did you all know that? Then I'm going to do 1.5. The exponent is here. X raised to the power of y. So I press that, and what it's going to do is it's going to kind of like highlight it. It's going to stay, meaning it's going to do that function. To the 9th, 1.5 to the 9th power. So then I press 9 equals 38.44, and then you multiply it by the 8 in front, times 8. 307.55. So that's how you do it on a cell phone calculator at home. So you can do your homework successfully, because this is a class set. Okay? All right, good. The number of subscribers to a blog doubles each week. Oh, my common ratio is 2, doubles. How can the trend in subscribers be modeled? Well, what does this screen say, the woman? In our first week, we had 5 subscribers. That would be our initial value. We did it as the y-intercept when we graphed it. They had 5 subscribers and it doubles each week. 5 subscribers and it doubles each week. I'm going to write this. So, this is going to be like we did just this week. A times b to the x. So this is an exponential function because it's a word problem. 5 times 2 to the x, remember? F of x is the same thing as y equals. They mean the same thing. The number of people, example 6, the number of people attending an international festival has decreased by 20%. This is decay. So, let's do 1250, the first year. Ratio. You guys, if it's decreasing by 20%, I have to do that formula that I did 1 minus 0.80 or 1 minus 0.20. Remember, if it's decreasing by 20%, I did decay where it was 1 minus. So, $1 minus 20 cents is how much? 80 cents. So this is my rate of decay, and the 80 is what I'm going to have in my A is my starting. What did I start with? 1,250. 0.80 to the x. How can attendance for the first 5 years be modeled? Replace x with a 5. Go ahead. Get on your calculator. What'd you guys get? How many people? All right, I'll just call on someone at random. Hunter.
I got 400.
Because remember, it's decreasing every year. The attendance, did everybody agree with him? The attendance is 409. At the end of 5 years. Okay? Big decreasing, right? That's not good. Okay. So, let's look at what our homework is. And since we have 20 minutes, we can start some of it. I want to do I want to model 35 for you. I want to do one from each section so that you're at least like feeling like it's not that bad. So, write the geometric sequence using function notation. 3/4 is the what? It's not the first term. A sub 1 is the first term. Not the initial value. Initial value is 20. That's the first term. Initial value is the same as y-intercept is the same as starting point. So in this formula, 3/4 is going to be my what? Ratio. So put an R for ratio. So now I have to use the other formula, which is this. A sub 1, 20 times 3/4 to the n minus 1. If you're given the first term, let me write this at the top of the paper. If you're given the first term, I'm going to use explicit, which is a sub 1 times the ratio raised to the n minus 1. If you only know the ratio, you do r to the a, and you just leave the n minus 1 as a n minus 1. And this is called recursive. So you need to know the difference between the two because it asks you sometimes to go from one to the other. Let me do 22. 22 is kind of complicated looking, isn't it? You guys, in your calculator, you need to figure out what 8/3 is. Because I need to know what these numbers really are, right? So it's like 8 divided by 3, 2.6. So I can like write it underneath it. 2, 2.6. I could also, let me do one more, 32 divided by 9. I want to show you another shortcut. So 3.5. This is my list. This is number 22. But, do you guys see, like, look at the numerators. What are the numerators increasing by? 8 becomes 32. 32 becomes 128. What am I multiplying by? 8 times what is 32? 4. Is 32 times 4 about 128? Okay. So 4 is the numerator. What's my 3 in the denominator? How does it become a 9? 3 times what is 9? 3 is 9 times 3, 27. So 4/3. Number 22. The common ratio is 4/3. Yes, it's geometric. So that's the first question. Is it geometric? Do I multiply by something? Geometric means I multiply. Yes. 4/3 is the ratio. And then I just write the recursive formula if I only know the ratio. 4/3 a n minus 1. So I'm going to cross out 25 and 26. Do not do those. I'm shortening this. I'm going to cross out number 30. I'm going to cross out 34, and I'm going to cross out 38. Just so it's not like tons. Now, let's do 127 through 29. Write the recursive formula for the sequence represented by the explicit. I am given explicit, write recursive. So on 27, the first term is 1/5. The common ratio is 10. Explicit is 1/5, 10 to the n minus 1. I'm going to write the recursive. My common ratio is 10. 10, parentheses, a sub n minus 1. And that's it. I'll put an R above the 10 so that you know that that's the common ratio. That was 27. 31. I am given recursive. Find the explicit. Explicit is when I know the first term. Oh, look, a sub 1 is 100. First term is 100. 100 4/5 n minus 1. That was number 31 that I just did. And then I did 35 for you. So recognizing, the top portion is recognizing how the numbers are changing. Like 20 is not geometric, so you don't have to do anything. There are a couple others that are not either. All right, I'm going to stop the video.